Welcome to the Chapter 6 Using Methods video. May break this one down into a couple of parts. Just depends on how quickly I can get through it, but there's quite a lot to cover. This is going to be something different, and you'll need to understand it as you go through our program. Hopefully this will help. So let's get into it. Okay, what is modularity? Well, that's simply the idea that you can reuse code by placing it in a special location called a module or function or subroutine. Method is really what we call them now. And calling that from another piece of code. All right. This allows you to share, pre-used, pre-tested code with other developers, and it can also reuse it from one program to the next for yourself. So that's the whole point of that. It cuts the development time, and when you get into Visual Studio development environment, you'll see there's 4,000 or 5,000 classes of objects that are pre-tested that are available to you. So you can get a lot done in a very short period of time without having to reinvent the wheel. Okay, so in order to execute a method or that block of code, you have to invoke it or call it from somewhere else. So you might have a main body of your program, and you may have a call to another method that calls another method, which calls another method, and then they return back to the calling portion until they get all the way back to main. So you can link, those things are kind of like linked lists, okay, if you think of it that way. So the calling method calls or invokes the method to be called. That's kind of redundant, but so modularization is the process of breaking down a large program into modules. Provides abstraction. Well, those are benefits because you don't have to know how the clock works in order to tell time. You just need a functioning clock. Now, sometimes it'd be nice to know, but you don't have to know, right? Reduces elimination and repetition. And as you saw in the first or second chapter where we started structuring code, and I told you that structured code could be bigger than unstructured code, and that's fine. And the way you get around that is to put repetitive code into modules and call them from different places. Makes it easier for multiple programmers to work on a problem, easier to reuse, provides implementation hiding. Again, you don't have to know how things work in order to use them. You just need to know what it is that the module requires from the caller and what you expect to get back from the module. So it's just a structure. You have to understand it. All these programs work that way. Again, I'm not going to go over this. I've just told you the difference between abstraction, not knowing the low-level details. I'm trying to get through this as quick as I can. You can read some of this stuff. It's not that big of a deal. It's just general information. Okay, reuse your code. All this amounts to is faster development, less cost, more profit. And that's what reusability has given us. So there's some rules for naming a method, and there's some rules for the construction of a method. Method names must be one word. I recommend you use the same procedure that you use for naming a variable. Okay. Method names should have some meaning, just like variable names should have some meaning. Okay. So they're basically, a method has to include three things. A header, which is like a for loop has a header. It's also called the declaration. Includes the method identifier and possibly other necessary identifying information, and that would be in the arguments list, and we'll get into that later. A method's body, which is also the implementation. That's the code you're going to run inside of it. And then a return statement. Now, this is very generic and does not apply to Visual Logic. You don't have return statements in Visual Logic. There are two different kinds of methods that you'll see throughout your career, and one of them is called a void method, and the other one is called a value returning method. So void method means there's no return type, there's no return value, so there's no return statement. All right. A value returning method returns a type of data back to the caller, and that's done with an assignment statement, and you'll see that in a minute. Okay, so here's an example of how you go about modularizing a program. If you see here, we have H, I, J, K on the no side, C, D, E, F, and here's another if. and H, I, and J again. So here is something for you to look at. Because I have duplicate code here, I could take this H, I, and J process, put it in a method, and call it here and call it here. All right? That's basically how it's done, and there's your statement. Now, here is your method. See, it's separate from your start and stop from your main body of your program. Method H to J. It's got process H, I, and J, and it returns back. Now, yes, it returns back to its caller, but that doesn't mean it returns anything to the caller. All right? So notice that the little call statement is a rectangle with a line through. I think Visual Logic has two vertical lines, but it's the same basic thing. So what happens here is you start the program, loads into memory, does A, looks at B. If B is false or no, it comes over here and calls this. Execution then jumps over to here, and it does H, I, and J, and it returns back to the caller, and then comes back to K. Now, returning back, this return is different than a return statement where it returns a value. That's two different things. But execution jumps back to the caller, is what that means. Same thing here. If B is true or yes, we do C, D, E, and F. If G is true or yes, then we come over here and call this. Execution then jumps over here, does H, I, and J, and returns back to here and finishes. Okay, so as you can see, we got rid of the duplicate code and made the process a lot simpler by encapsulating this into a module or a function. Oops. There's some do's and don'ts here. They talk about scope. One thing I don't want you to do in Visual Logic, so make a note of this, and when I tell you to change the arguments from the caller to the actual method, there's a reason for that. You shouldn't be using global variables and constants. That kind of goes against object-oriented design, and as you can see here, that's what's going on. And they're actually not supposed to be available anyway. But in Visual Logic, guess what? If you name them the same, you can have access to them. So we're going to change the names of these as we go through here, and I'll show you, how to get around that. But you can't name them the same. That's just not going to work. Okay, so here's name and address. That's a method call. They've got some constants here. What you would really do is you would pass these constants in as arguments into this argument list. Then it would have access to them locally, but they would be copies of these, right? So it runs this output line 1, 2. So it doesn't, this is correct. You should not do this. And here's where we talk about visibility and scope. Typically, when you declare something in scope level, in block level, like your main implementation of your program, it's not visible and not accessible to other methods in your program, okay? And that's the way it needs to be for security reasons. You don't want your program inadvertently changing values on you, which can happen if it's visible throughout the program. Also, doing it this way makes it more portable, reusable, easier to use without having to change very much in it, okay, or if anything. So local variables are what they mean. They're local to a method or to a block of code, and they're only available while that code is running, and they are destroyed or removed from memory after that little bit of code finishes in that method. And they're not known to other methods. Global variables are those that can be seen through the entire program at program level. That is not the way to go. And I'm sorry that Visual Logic, it's a Freudian slip, does that. And that's why I have you change those names, okay? So that you have to address it, because you're going to have to address it later anyway. So encapsulation states that a task's instructions and its data should be contained in the same method. So in order to do that, to keep encapsulation as the rule in a program, you have to actually pass these data elements from one place to another, all right? That's how that works, and I'll show you that in just a minute. So methods or functions or whatever have arguments, right? Arguments, and you've seen this if you've done anything much at all, you'll see the method name, an opening parentheses and a closing parentheses. Sometimes there'll be nothing in those parentheses, but that's your argument list. You don't have to have any, but if you put them in there, the caller has to have the exact same number and type as the actual method itself. So the type of the parameter and the local name of the parameter. And that's the parameter list, or actual argument list, if you will, depending on what book you're looking at. Now notice compute tax num amount. What does this tell you? That, well, there's your argument list. See that? Let me see if I can zoom in on this a little bit. I don't know if it'll let me. Whoops, no, it's not. Okay, well, let's do it like this. Okay, there we go. So it says compute tax num amount. See the opening and closing paren? That could be empty, or it can have as many as you need in there. But you know, if you got more than 5 or 6, you got too many. You need to rethink it. But the more you have in there, the more memory it takes. But it doesn't matter. All right, you got to do what you have to do. That's the data type, and that's the name of the argument. Now these are local variables, is what they are. They're local to this method. So when this method gets called from main over here, it takes the price variable you just got as input, and it creates a copy of that and passes that on when execution runs up here and sticks it in this temporary variable called amount. That is temporary because it only exists while this is running here. And that also means that you don't have access to this in here typically by default. All right. And basically there's some calculations and you output and you return back to here and then you stop the program. See if I can get zoomed back out here. Oh well. There we go. Next page. By default, these parameters are passed by value, okay? Which means it's a copy. By value is just a copy of the value of the variable in memory, okay? No matter what you do in that method to that copy, it's not going to change the original value in memory. That's what passing by value means. You're protected. You can do whatever you want to it, but it's not going to change the value. That's a key seminal point here, all right? If you pass by reference, what you're doing, instead of passing a copy of that parameter, you're passing the actual memory address pointed to by the name of the variable. That means that you can change the value in memory, but it's kind of dangerous to do that. Sometimes you need to. But that's why this has to be explicitly declared that way. Otherwise, by default, it's automatically by value. And you can have, like I said, you can have as many parameters or arguments as you need in a method argument list. They're separated by a comma, so it's going to be the type of data. It's either num or string in this class. The name, comma, space, type, name, comma, space. And so when you call from, let's say, main into this particular method, you have to have the same number, order, and data type from one to the other. Otherwise, you're going to have a problem there. Okay. Really, the best way to get into this is through the in-class lab, and I have a video on that. So here we have, how many arguments do we have here? See that comma? We have 2. They are called amount and rate. Notice that their names are different. They are both of type num. These are both of type num. If you look up here, you'll see that. So they're getting the price and the tax rate. They're calling this method, and they're passing in copies now, because this is by default passed in by value of what's stored at price, sticking it in this little temporary variable called amount, and what's stored at tax rate, sticking in this little temporary variable called rate. These are temporary and they only exist as long as this exists. Now I can do anything I want to amount and tax in here. They are copies of price and tax rate. That will not change what's stored here because they only exist as long as this is run. They're only copies. So there's nothing you can do to price and tax rate inside of here by using the name, amount, and rate, unless you declare them as passed by reference, which we'll talk about in a minute again. As you can see, you're passing copies here in your pseudocode. Okay. Return type, you only have a return type if it's a value returning function or method. If it's a void method, there's no return statement and there's no return type. And that just means that it doesn't mean it doesn't return back to its calling code. It always does that. This has to do with whether the method actually returns a value back to the caller. Okay, now here's an example of a value returning method. There is where the actual data type that it returns comes back. So hours has to be of type none because that's what this is returning. See that? Return work hours. And in order to do that, now this is key to value returning methods versus void methods. Value returning methods have an assignment statement, just like when we change the value of what's stored in a memory location of a variable, we use an assignment statement. So what happens here is it goes down, and when it hits this call right here, execution just sort of goes into suspended animation right here. Jumps over to here, passes in, well, there's no argument list here, but execution jumps over here. It does its thing, input hours work, and then returns work hours back over to here. At that point, you can, in your mind's eye, scratch through this method and put the value returning back here, and then the assignment takes place. You take that one value on the right and stick it in the memory location pointed to by the name on the left. Now hours has a value here that came back from this method. Okay, well, it wasn't as long as I thought it was. And I know there's a lot for you to look at, but when we get into project 6, I think it'll make a lot more sense. And the in-class lab will help you too. I have a video for that. So I will see you next class.